This video is about how to find vertical asymptotes of a rational function. So we have three rational functions here. We're going to find the domain of each one, and then we're going to find the vertical asymptotes of each one. Okay. A rational function in lowest terms has a vertical asymptote at x equals r if r is a zero of the denominator. So let's look at this first function here. We have 2x over x squared minus x minus 6. And the easiest way to do these is to factor the numerator and the denominator if possible before you start. So I'm going to do that. The numerator here, 2x, can't be factored. That's as simple as it gets. So I'll put that on the top. 2x. The denominator here can be factored. This is a trinomial with a leading coefficient of 1. So we can factor that as x plus 2 and x minus 3. X plus 2, x minus 3. Alright, first thing we have to find is the domain here. The domain of a rational function is all real numbers with the exception of any x values that would make the bottom of the fraction 0. So this fraction here would be 0 if x were equal to negative 2 or if x were equal to positive 3. So our domain is going to be the set of all x such that x is not equal to negative 2 and x is not equal to 3. Okay, once we've found our domain, the vertical asymptotes are very easy to find. There's a vertical asymptote everywhere this function isn't defined. So x equals negative 2. This is supposed to be non-equals. X equals negative 2 will be one of our vertical asymptotes. X equals negative 2. And then x equals 3 will be our other one. X equals 3. Okay, next function here is 2x squared over x cubed minus 125. So the top, again, we can't factor at all, so we're going to leave it the same. 2x squared. And the bottom, you might not remember how to do this, but the difference of two perfect cubes, we have a subtraction sign, so it's difference, and these are both perfect cubes. The difference of two cubes can be factored as, well, this one would be x minus 5 times x squared plus 5x plus 25. So if you multiplied this out, you would get back to x cubed minus 125. Now, if you don't remember how to factor that, you could still get through this problem without too much trouble. I'm going to erase this and show you how I would do it if I didn't know how to factor that. That actually didn't help us too much. We would want to factor the trinomial there too. Okay, so we need to figure out what values of x make the denominator 0, because those are the ones we need to avoid in the domain. So I can kind of tell that, well, when x cubed is equal to 125, then the denominator will be 0, because then we'll have 125 minus 125. So we need to figure out when x cubed is equal to 125. The two numbers I want to check are 5 and negative 5, because 5 cubed is 125. So if we plug in 5 here, 5 cubed is 125, minus 125 would give us 0. So that's one spot that definitely is not in the domain. So x such that x is not equal to 5. Well, we don't know if there's going to be another one. Now we need to check when x is negative 5, is this also equal to 0? So negative 5 cubed is going to be negative 5 times negative 5 is positive 25. Times negative 5 again is negative 125. So negative 125 minus 125 is going to give us negative 250. So that is not a 0 of this function. So f of x would be defined at negative 5. So this is our domain. All x such that x is not equal to 5. Now that we have that figured out, it's easy to find the vertical asymptotes. X equals 5 is going to be the only vertical asymptote, because that's the only place where x is not defined, or the function is not defined. So x equals 5 here. Okay, last one here. We're going to start off by factoring the top and the bottom. X squared minus 49 can be factored as x plus 7 times x minus 7. On the bottom here, x squared plus 4x minus 21 can be factored as x plus 7 times x minus 3. Because positive 7 and negative 3 multiply to give us negative 21, and they add up to positive 4. Okay, now we have to make sure the function is in lowest terms. We do have a common term on the top and the bottom. So we're going to divide the top and the bottom polynomial both by x plus 7. We're allowed to do it if we do it to the top and the bottom. And that will help get rid of both of them. We also call that canceling if we're not in the mood for thinking through what we're actually doing. So let's get rid of these. We divided the top and bottom both by x plus 7. So now what we have left is x minus 7 over x minus 3. So we need to figure out where the denominator would be equal to 0. That's going to be 3 because 3 minus 3 is 0. So our domain is going to be all x such that x is not equal to 3. And then we'll have a vertical asymptote at x equals 3 because that's where the function is undefined. So this is our last vertical asymptote.